Okay. Okay, Venturi is some kind of tube, look like this. Okay, the idea, you might learn this, I don't know you learned this before, but you will learn this in unit operations. So the best idea is the narrow the area. The narrow the area. Narrower. The higher velocity. And lower pressure. Okay, so it guys, we call it straw sections. So it has a very narrow straw sections. The tube with a very narrow straw section. We call this Venturi. Okay, so this kind of air control device is based on this principle. Okay, so this is called Venturi scrubbers. So this also kinds of air pollution control device. Okay, so this kind of device helps us to remove particles. Remove particles from gas using water droplet. Okay, Venturi scrubbers, okay, is good for removing particles from gas using water droplet. Okay, so the idea is the dirty gas plus water droplet, right? 水珠啊 water droplet. Because the structures, the narrow straw. Okay, so plus high velocity mixing. So those particles will attach to water droplet. Then it's easier to compare with the particle and water droplet. It's easier to remove water droplet, right? Then you separate water droplet from air. So this is the concept. Okay? So in Venturi scrubber we use water droplet mixing with dirty gas. Okay, dirty gas. Some particle from dirty gas. And those particles will attach to water droplet. Think about it. Is that easy to remove particle from air or easy to remove water droplet from air? Of course, it's easier to remove water droplet, right? Okay, so Venturi scrubber, right? It has a narrow throat, as I show you. Okay, so when gas enter this narrow straw, okay, so when gas enters narrow straw, what gonna happen? The velocity increase, right? When gas enters the narrow straw, as I just showed you, right? This is the concept. The narrower the area, the higher the velocity, the lower the pressures. So when gas enters the narrow straw, the gas velocity increase. Okay? And if the gas velocity increase, it helps improve contact between particles and liquids. Okay, so the high-speed gas helps improve contact between particles and the liquid droplet. So velocity accelerate means increase. Okay, by the factor of four times. 变4倍了。Normally increase to 4 times in the slow section. So gas velocity increase 4 times.速度增加变4倍到那个 narrow straw. And we want higher speed because the higher speed gas help improve contact between particle and liquid droplet. Okay, the high speed causes atomization. Okay, you might know atom, right? Atom is very small, right? So that means the high speed causes atomization of liquid. That means this equals many tiny droplets. Okay? Atomization of liquid equal many tiny droplets. Okay, you know atom, right? So that means the higher speed gonna break down the liquids into many tiny droplets, very small droplets. And smaller the droplet, student, the smaller the droplet, the higher the surface area, right? Okay, so this also increase, the smaller droplet also increase surface area. Okay, and also in the slow regions, you're gonna create lots of turbulence. So it's good, result in good intermixing. So after that, we need a separator. We need a separator to try to separate the water droplet and gas, right? So what kind of separator we can use? Okay, I already mentioned here. Okay, we can use cyclone, the one we learned previously, right? So we can attach a cyclone to it. Try to separate particles and liquid. Okay, try to separate water droplet. Ketchup particles and also some mist. Okay, so the separate removes water droplet, ketchup particles, and mist. Okay, let's practice one more question. Okay, everyone okay? Okay, this question, this is also the collection efficient question. Okay, and but this is proposed by this guy, okay, or these three guys. Okay, proposed by these three guys. So the eta, eta is collection efficiency. Is 1 minus exponential minus kappa. Kappa is the correlation coefficient. Times R. R is the liquid flow rate. Square roots. This is this line equals inertial impaction parameters. Okay, and this parameter is defined by this. Okay, so this is good for the particle and droplet. So this equation is good for the Venturi. The Venturi. Okay, so this is good for Venturi. The equation is good for Venturi squadron. Okay, so the reason this equation is good for Venturi because we have this inertial impaction parameters. Okay, and this parameter relate to the particle and droplet sizes, right? So of course this is good for Venturi scrubber. So this parameters pronounced as C, PSI, C, okay, pronounced as C. Okay, so next, and this is C. Okay, this parameter C stands for the coming hand correction factor. Okay, and the coming hand correction factor is defined by the next slides. Okay, by the equation 9-68. Okay, so the dP is diameters of particles times absolute temperature, K. So if C is close to 1, what we mentioned here. If C is close to 1, that means the slip effect can be known. The slip too small. If C is close to 1, the physical meaning means the slip effect is too small, which can be known. If C larger than 1, that means particles move fast. So you cannot ignore slip effect. Understand? The slip effect comes. Have you Stone？ 你们有学过这个吗？Counting and correction 有学过吗？在单元 unit operation 还没有 ？Okay. So you probably haven't learned this before. So I have one more slide. So this slide proves, okay, show you how to derive this. But in this course, okay, as I mentioned, in this course, I will not ask you to derive, okay? In the transfer phenomena course or in unit operation, I will ask you to derive, but not in this course. In this course, you just need to know how to use the equation and what does those numbers mean. That will be good, okay? Okay, let's finish this up. Okay, example 9-15. Okay, so this is for do you see that? Do you see a keyword? Venturi, right? This is a keyword. So if the question asks you the correction efficiency, student, you cannot use this one. Okay, this guy is for ESP. Understand? This guy, student, take a look here. Look at the Bravo. This one is for ESP. And this one is for Venturi scriber. Okay, because it got some correlation coefficient. Correlation means collection, okay? Means correction. Okay, so it got this parameter C, right? This C parameter relates to particle and droplet size. So that's very obviously very important characteristics of Venturi scriber, right? Okay, so we almost have everything, right? But we don't have particle density. Here. So particle density is 700 kilogram per meter cubic. And minimum, okay, minimum particle size equal 10. Okay, then we have everything. Okay, first of all, Okay, student, okay? Let me enlarge this. For doing this question, first check C. Because I want to see C is close to 1 or larger than 1. Okay? So this after calculation, the C equals 1, close to 1. That means we can ignore slip effect. Okay, you don't need to care about the slip effect in this case. Okay, that means this question will be simpler. Okay, second, you need to calculate VG. VG. Okay, VG, what is VG? VG is gas velocity. So the gas velocity equals QG over AT. QG over AT. So the VG is 94. 94.40 over 1.00. So it's 94.40 meter per second. This is very high gas velocity. But this is reasonable. Why? In throw area, right? In the narrow throw area of Venturi. This is super high gas speed, but reasonable. Why? Because we use Venturi. Understand? So the speed is very high in the throw area. So this is reasonable. Okay, this is typical. This is reasonable. If not in Venturi, I would doubt about it. Okay, but in Venturi, this is very reasonable and typical. Understand? Okay, so next we need to calculate C. Okay, it pronounced P. PSI. Okay, it's Greek alphabet. Okay, the P doesn't pronounce, so it's pronounced as C. Okay, so after that, okay, just based on formula, okay. So we got this guy, 1.46 dP squared. Okay, we also missing something called R. R equal QLO over QG. So QLO is 0.13. QG is 94.40. So we got 1.38 times 10 to the power minus 3. Alright, now we really have everything. Okay, so we just plug in and we got this. Okay, now finish it. So dP, we know dP, the dP is 10, right? 10 micrometer. The dP is 10 micrometer. So 1 minus exponential minus 0.33 times 10. So the answer will be 96.3%. So the answer of this question is 96.3%. Okay, let's finish this up. Okay, if you finish, please go to our online group. Please go to our online group or Moodle to download the new PowerPoint slides. So we are going to talk about the noise pollution. So after that, we will finish the so this is the second last. 倒数第二个 the noise pollutions. So after this, we're going to talk about the hazards. And we finish. Okay? Student, please go to our online group. Okay, please go to our online group. Or please go to our online group or Moodle to download. Okay, please go to our online group or Moodle to download. Okay, and also I already post assignment 2, assignment 3. Okay, so assignment 3. When is the, let me check, what is the deadline for assignment? So, May 20 is a deadline for homework 3. Okay, May 20, early. So, do you guys, do you, if the new student know early? Early in Mandarin sounds like I love you. Okay, so early sounds like I love you. Okay, so remember to submit your assignment 3 on May 20 because I love you guys. Just kidding. Okay. And we have one more assignment. Assignment 4 probably will due because we are going to have an exam, right? May or June 4th. So you got due. Let's say 21. Okay? Then I will also give assignment 5. But assignment 5 is just for practice. Okay? You don't need to submit assignment 5. I will give assignment 5 with answer. So on May 30, I will give the solutions of assignment 4. Okay, and also solution for assignment 5. But you don't need to submit assignment 5. Okay, this semester we just have 4 assignments, 5 points for each. Okay? And remember, June 4th is going to have our final exam. So it's not here. Student, our final exam will not be held here. Okay, our final exam will be held on the main campus in IB. Will held in IB 501. Okay, our final exam will not held here. Understand? Our final exam will be held in IB 501。把那个同学叫起来，睡个爽。好了，算了，把他叫起来。他不舒服。 哦，那不舒服。OK， 期末考是在501 IB 501 ，OK， 不是在这边哦，不要跑来这里哦。OK，the final exam will be held in IB 501, not here, on main campus. If you understand, please raise your hand. Okay, everyone understand, right? Don't come here. 501. Okay? Okay, those are good news. But I have a bad news for everyone. Okay? I have bad news for everyone. The EMI office informed me that because last time we have a survey, right? Is that because we have 20 students registered in this course, so it required 12 students to fill out the survey, but only 7 students fill out the survey, so we failed. So we will not get the money. Okay, we will not get the $2,000. So and also our department have a new rules that the department always asks the teachers, asks the professor, not to treat students in class. Okay, so the pizza party will be cancelled. Okay, but don't be sad. Don't be sad. We still have a chance. Okay, maybe sometime in summer if you're still around. Okay, if you're still around. Okay, I will buy you guys pizza. Okay, but not for the course. Okay? As a friends. Okay. They say that if I buy you guys pizza, I'll buy you guys food. It's something like try to bribe you. So it's no good. They forbid the professor to buy food for students. So the pizza party will be cancelled. Okay? But we still have a chance, okay, as a friend in the summer vacations, okay? Not in the course. Okay, I will buy you guys food. Okay? But not for any purpose. Just for friendship. Okay, just for friendship, not for any purpose. So the pizza party will be cancelled. Okay, let's move on to the second last topic, the noise pollution. Okay? Everyone okay? Okay, you might learn this before in the physics course, right? There are two kinds of wave, mechanical wave and electromagnetic wave. But in these lectures, we will not talk about electromagnetic wave. Although electromagnetic wave is also some kind of pollution. Okay? Because we are going to talk about noise. So we are going to talk about mechanical wave, especially longitudinal wave, which means the sound wave. Sound wave is one kind of longitudinal wave. Okay? So there are two kinds of volcano wave. One is longitudinal. The other one is transverse, right? So this is longitudinal. Okay, you might notice in physics before, right? So compression, rarefactions, compression. And this is transverse, like water. So water is transverse. All the rope, okay, rope is transverse. And the sun wave is longitudinal. Understand? Okay. Okay, so let's see some nature of sun. Okay, sun is a vibration of molecules. Okay, also I forgot to mention this. The difference between mechanical wave and electromagnetic wave is mechanical wave require medium. For example, like air, for example, like water. But electromagnetic wave do not require medium. Understand? So electromagnetic wave like light, it can transmit in vacuum. Vacuum means no air, right? No other mediums. So the difference between mechanical wave and electromagnetic is medium. Okay, so without medium, there is no sun. The sun cannot be transmitted. Okay? So the sun is a vibration of molecules in medium. In medium. For example, like in air or in water. Okay, that can be heard by human. Okay, can be transmitted through liquid, solid, or even gases. Those are something called medium. Okay? And sun cannot travel. The sun wave cannot travel in vacuum. Without vacuum means nothing there. No air, no water, right? Vacuum. Alright? The sun cannot travel in vacuum. And the sun wave is longitudinal wave. Sun wave is a longitudinal wave. So which has a compression and rarefactions. So it just moves back and forth, right? It just moves back and forth in the same directions. Okay, so how to find out the wavelengths? So you find one spot here. One spot here, one spot here. So this is in the middle parts. Okay, maybe in the middle parts. And the middle parts are refractions. So this is wavelengths. Okay, this is wavelengths. The length of from this point to this point is the wavelength, and this is the amplitude. So the amplitude shows how strong the vibration. So you speak louder, student. Speak louder means the larger the amplitude. Doesn't mean you're gonna transmit faster. Understand? Speak louder doesn't mean your some wave will transmit faster. No. Speak louder means this web. Speak louder means, for example, I speak like this, and I speak louder. I shouldn't use. Okay, although this is not right. This is transverse, right? But I speak louder, so the amplitude become larger. But frequency will be the same. The rate, the transmission rate will be the same. Understand? If you want to change the rate, you need to change the medium. Understand? You might learn this in physics, right? Okay, if you forgot, go back to read the chapter of this in the physics book. So the amplitude equals energy. Okay, the amplitude equals energy. It's proportional to energy. I just draw this and I say this is wrong, right? Because this is something called transverse wave. But the sound wave is longitudinal. So this is a question from the previous student. Okay, he asked me, why is the sound longitudinal? Okay, why the sound longitudinal? Okay, we will come back to here. Okay, now is 3:10. Let's have only 5 minutes short break because I'm going to leave it around 5.